If you have any questions during the webinar, please use the box in the upper right corner of your screen to submit them. All questions will remain anonymous and will only be seen by the presenter. If we do not get to all questions, we will send out the answers in an email later on. After the webinar, you will be receiving a certificate of attendance, a link to the recording of this webinar, and information on next week's webinar on industrial dampers with Ruskin product expert Cody Masser. Thank you again for attending, and I will now turn it over to Jim to begin the presentation.
Good afternoon, everyone. My name is Jim Smardo. I'm the National Sales Manager for Louvers and Architectural Sales. I've been with Ruskin over 26 years and am currently the Amca Louver Marketing Task Force Chairman. So today, some of the subjects we're going to discuss is going to be briefly about Amca certification and listing, hurricane and coastal zone regions from Mexico through Maine, briefly touch on Florida louvers and the new code coming out, FEMA tornado louvers, ICC 500 guidelines, and blast and anti-terrorist louvers. So Amca is a third-party association that sets testing standards and guidelines and certifies and lists products for manufacturers. They test products for the parameters that are specified. Amca checks its data against manufacturers' literature, certifies products to bear an Amca seal. They have a listing database online for Hurricane, Amca 540 and 550 listed products, and they require a check test to maintain certification. So Amca has guidelines for testing in louvers, and those are under Amca 500L, which consists of pressure drop, water penetration, airflow, wind-driven rain, wind-driven sand, and sound performance. And in 2015, Amca introduced Amca 540 and 550, which is testing and certification for hurricane zone regions. So these are some of the agencies that list and certify louvers for hurricane, Florida, FEMA, and blast louvers. So you have Amca, you have Miami-Dade, Florida Building Code. Texas Department of Insurance is fairly new, and they go by Miami-Dade NOAs. And then you have agencies that do testing like UL, Intertech, and NCTL. So the definition of a hurricane zone area is any building of risk in Category 2 along the Atlantic and Gulf Coast with a design wind speed of 115 miles per hour or greater. These are louvers that are designed to withstand hurricane conditions of high velocity wind-driven rain and impact. And with the introduction of storms on the East Coast, hurricane zone has become an area of Mexico all the way up through Maine. So a little background on what happened. I believe Ruskin started building louvers for hurricanes around 1984, but in 1992, Hurricane Andrew made landfall. It was one of only 5 hurricanes that has ever made landfall that was a Category 5 hurricane. It caused over $25 billion in property damage, recorded over 65 deaths, and it really started the code reform to strengthen buildings. So when the code started changing, the original test protocol was TAS 201, 202, 203, and 100A. And I'm going to go over those just a little bit because afterwards there was the introduction of Amca 540 and 550. So TAS 202, and I'm going to skip 201 right now because I want to bring it up with Amca 540 because I think that's where a lot of the confusion starts. So TAS 202 is static pressure test, which tests louvers' ability to resist hurricane force winds. And this is a positive and negative pressure of 1.5 times the design load. So for example, if there's 150 PSF on the design for the tested louver, you have to run that test up to 225 PSF. And this is a pass-fail test. And one of the things that I think confuses people is similar louvers by different manufacturers will have different manufacturers' maximum single section sizes and different design loads. But the louver manufacturer determines the maximum size and design load, and that's what causes the confusion with different sizes and different loads on these louvers. TAS 203 is cyclic wind pressure. That's a test where the louver after the impact is put into a chamber and positive and negative loads are applied to it. 600 cycles at 40% of the design, 70 cycles at 60%, and then running the pressure up to 130%, both positive and negative, on the design load. And that is a pass-fail test. And that has to be done after the TAS 201 impact test. So in 2015, the IBC came out, and in chapter 1609 in Louvers stated that louvers protecting air intake and exhaust ventilation ducts not assumed to be open and located within 30 feet of grade shall meet the requirements of Amca 540. So hurricane louvers, a windborne debris definition, is an area within a hurricane zone region within 1 mile of the coastal high water line with the design wind speed of 130 miles per hour or greater. All areas where the ultimate design speed is 140 miles per hour or greater is determined to be a wind debris zone. And these are designated through building categories 1 through 4. So category 1 is agricultural, and category 2 are buildings that present a low hazard to human life in the event of failure. These have wind gusts up to 175 miles per hour and are rated for occupancies of 300 people or less. Category 3 and 4 are structures with greater than 300 people, schools, adult education, power generating stations, structures like that have greater than 300 people. But also category 4 structures are designed as essential buildings. These are fire stations, hospitals, emergency treatment facilities, water storage and pump stations. These are buildings that are deemed essential, which means they must stay open during the event of a storm. These louvers have to meet an impact level of level E, which is a 9-pound 2x4 at 55 miles per hour. So now we'll talk about Amca 540 versus TAS 201, because I think that's an area where there is confusion. As you can see, both of them require a 9-pound 2x4 at 34 miles per hour, or approximately 50 feet per second. But the original test protocol was set up on testing curtain walls. And the larger the window, the more difficult it is to pass an impact test. But the exact opposite is true for a louver, because the longer the blade is, the more deflection it will take. So when Amca 540 was introduced, they accepted the largest span, both single section and multi-section, but they also decided that they would require testing for the smallest louver offered, and this is a pass-fail. And since most louver manufacturers build louvers as small as 12 inches, the testing minimum size of 12 inches by 5 blades or 36 inches tall is the biggest differences in the test. So this chart on this slide basically shows the two different tests. And you can see all of them are identical, except the fourth column down on TAS 201, where it does not require the smallest section to be offered. Both of them are 2x4s, both of them are 9-pound tests. Both of them require the largest single section and the largest multi-section, but TAS 201 does not address minimum size. So I think confusion between 201 and 540 was that in itself. 540 is more difficult to pass with smaller louver impacts required. A minimum of 5 blades tall and 12 inches wide. So if you take a 12-inch louver that has an inch on each side for a jam, you're impacting that blade in an enhanced test with a 9-pound 2x4 at 50 miles per hour on a 10-inch blade, and that becomes very rigid and very difficult to pass. The difference also is, and this is the reason that Miami-Dade would not accept AMCA 540. Miami-Dade requires TAS 203, the cyclic test, to be run after impact, and AMCA 540 did not address the cyclic test, and that is why Miami-Dade up until this point has not accepted AMCA 540. Now this becomes a big issue for louver manufacturers throughout the country because we have to do two tests. We have to test for 540 maximum sizes and minimum sizes, and then we have to test for Florida to do impact testing plus TAS 203. And that's what we're trying to work out with that. There's also differences that 540, when it was written, did not address the installation or the attachment to the wall opening, and Miami-Dade does. There's a slight difference in the distance from the cannon to the test sample. AMCA 540 states that it is 1.5 times the length of the missile, and TAS 201 says that it is 9 feet plus the length of the missile. So using an 8-foot 2-bore, AMCA would be 12 feet from the sample, where TAS 201 would be 17 feet. And while the initial velocity is measured coming out of the cannon is the same, the difference traveled means there's a more severe impact with AMCA 540. Now currently the Louver Marketing Task Force is working through a consultant with Florida and with Miami-Dade to see if we can get them to accept 540. And I believe there'll be some changes in code for 540 that will probably address cyclic testing. But currently the Louver Marketing Task Force is working to get Miami-Dade and Florida to accept 540 in some capacity. The International Mechanical Code in 2015 introduced AMCA 550 in Chapter 401.5, stating that louvers that protect air intake and exhaust openings in structures located in hurricane-prone regions shall comply with AMCA 550. So if you go back and look at basic testing for performance for water, you have 3 different tests, and I want to show you the difficulty of passing AMCA 550 or TAS 100A and why currently there are so few louvers that meet this requirement. AMCA 500L with AMCA testing for still air louvers or non-wind driven rain louvers is a gentle rain of 4 inches per hour running down the face of the louver with a fan at the back of the test chamber that pulls air through the louver and maxes out at 1,250 feet per minute. That's why you see louvers that test at 0.01 ounces at 785 feet per minute or 956 feet per minute. That is a test where you shut the test down once you start to draw water, and that's the certification point. Wind-driven rain testing for AMCA is at 2 levels. 3 inches of rainfall at 29 miles per hour and 8 inches of rainfall at 50 miles per hour. This is the same fan pulling air through the chamber up 1,250 feet per minute, but water is forced onto the face of the louver at a rate of 3 inches and 8 inches with winds simulating 29 and 50 miles per hour. And these are class A, B, C, and D, which rates the rejection or the efficiency of these in rejecting water. But you can get a class A, B, C, or D. When you look at hurricane testing, it is 8.8 inches of rainfall at different levels up to 110 miles per hour, but it is a pass-fail test. So you can't perform and get 95% of the water stopped and say you're class B. You either pass the test or you fail the test. So TAS 100A and 550 are pass-fail tests that are very difficult to pass. Here you see the chart, and you can see 35 miles per hour wind speed, 70 miles per hour wind speed, 90 miles per hour wind speed, and 110 miles per hour wind speed. So the test conditions are a meter by meter core louver, a rainfall rate of 8.8 inches per hour, wind speeds at 35, 70, 90, and 110 miles per hour. And I will tell you that most louvers start to fail on this between 70 and 90 miles per hour. And there are still currently no horizontal louvers that meet this test, because Amca 550 only allows 1% of the total amount through the whole test to infiltrate the louver, and TAS 100A only allowed half of that, a half of a percent of that total amount of water before it was a failure. So you can have a horizontal louver with a damper at the rear that will meet Amca 550. But recent code changes have stated that if there's a damper at the rear, you must state that the damper only meets 550 in the closed position, which in essence means you have to shut your system down with a damper at the rear to meet hurricane performance wind-driven rain. Now you can stop the rain with a horizontal louver at 110 miles per hour. But the problem is the way a louver drains water to the jambs and down through the front, it's impossible to drain the water before the water is picked back up and thrown back into the louver and overwhelms the louver. So you can design a louver horizontally that will stop the water, but you can't change and channel that water away fast enough. And that's why currently, when TAS 100A was in place, there were only 2 louvers on the market that met that water performance. And that is why Miami-Dade has accepted Amca 540, because allowing 1% of that water to be a pass has allowed multiple manufacturers to offer vertical louvers that will meet that requirement. But the code did change to dictate that louvers with dampers at the rear must state that the damper only meets that in a closed position. Another thing that I think is confusing that I wanted to talk about was wall types. So I think that there's a big confusion, because when we started doing louvers years ago, the most prevalent louver on the market was a sleeved louver. And you slid the louver in, and there was a front flange on the louver, and there was a continuous 2x2 clip angle on the rear. And you didn't require it to be anchored into the system, because it was basically wedged into the wall. But when we went to clip angles, and most of the manufacturers in the louver industry went to a clip angle install, what you have to understand is, because of the minimum edge distance, different wall types require different installations. So taking an EME 520 MD, which is a 5-inch horizontal louver, you can see that the minimum wall requirement for wood is 7 3/4 inches. For steel, it's 7 1/4 inches. For concrete, it's 10 1/4 inches at the jamb, and on slabs at the head and sill can be as much as 17 1/4 inches. And since CMU comes in 6, 8, 10, and 12 inches, there are a lot of different applications where the wall thickness becomes very, very important with the installation of the louver. And the next statement there, where it says the louver manufacturer is not responsible for the structural integrity of the louver opening, the permit holder is responsible to verifying the structural integrity of the building structure and the louver opening. I think that causes a lot of confusion. And that statement came from a competitor of ours directly off of their NOA. So almost all louver manufacturers will make that statement. And I think far too many times people understand that there's a louver opening, whether it's 48 by 48 or 80 by 80, but they don't understand until the louvers have been ordered and possibly even built that the difference in the wall type is so important. And you can see that by the statement about the louver opening, which is taken from a competitor's NOA. So I wanted to show some of the different wall types. and some of the different attachments when it comes to installing a Miami-Dade louver that has to meet anywhere from 110 to 165 PSF wind load design and impact. So in the upper left-hand corner, you see this is how you test a louver. You build a wooden buck and you test the louver, and then you calculate for all of the different other wall type installations, because no one could go back and do testing on all of these louvers on concrete and steel and wood. So you test it in a wood buck, and you can see on a wood buck, there's 1.5 inch minimum edge distance. Over to the right is a steel application, which is the best install because you have only 1 inch of minimum edge distance. The bottom right shows how you would install a louver with a universal sleeve. As you can see, there's a front flange. There's a clip angle that is screwed into the sleeve, but there is no anchorage there. And this was kind of pushed back by the industry because of the cost of the sleeve. But many times when you look at the wall thickness and the different types of walls and the cost of anchoring a building or a louver into a building, whether you're using Tapcons or whatever you're using, many times the cost of that anchorage and the time and labor for anchoring it is offset by putting it into a sleeve. But clip angles is what is driving the bus, and so that this is what became of it. But if you look at the upper left-hand corner, the bottom left-hand corner, I'm sorry, this is a CMU install. So imagine you've done this and you don't realize there's a CMU. And that direction of load goes the opposite direction. It's 4 inches, but it's not parallel to the louver placement. It's basically perpendicular. That angle is a 4 by 6 by ½ inch angle, and it gets very expensive very quickly. So this really states the importance of understanding the wall type. So if you look at the secondary attachment at CMU walls, it's very difficult to do and very time consuming and costly. Next slide, please. Thank you. So one of the things that we've done and other manufacturers has done is reverse the angle on the clip angle. This is very good for grout filled CMU, and it's also very good for walls that don't have the required thickness or depth. So you turn the angle the other way and you still anchor it into the wall. What you need to understand on this is if you do this, you have to undersize your louver more, because the clip angle must be installed into the wall structure and anchored, and then the louver is put in afterwards, which means that the deduct on your louver goes from 1/8 of an inch all the way around and 1/4 of an inch to 3/8 of an inch, and the installation is actually different. Typically when you install a louver with a clip angle, the clip angle is attached to the louver, or the louver is put into place and then the clip angle is put in. So in this case, the clip angle is put in first. But I wanted to show all of the different details that you get with installations requiring wall types and how it can impact your installation time and also your cost. The new Florida Building Code will come out hopefully in December 31st of 2020. There has been some talk about delaying this, but in essence, when you look at Florida, Miami and Broward County have to have Miami-Dade NOAs. That's a notice of acceptance. A lot of the rest of the state can do Florida Building Code, but the new Florida 2020 Building Code is supposed to come out December 31st of this year. Now, when you look at the Florida Building Code, this is louvers that are approved for use in the state of Florida. Florida code has based on the IBC and the IMC. So Florida has accepted 540 and 550, 540 impact and 550. One of the issues though is usually when you get Florida approval, you've given them the testing requirements for Miami-Dade. Miami-Dade louvers are always Florida approved, but Florida louvers are not always Miami-Dade approved. But one thing I would say about Florida louvers, they're based for Florida louvers, but anywhere in the country, if you would have a louver that has a greater wind load requirement than the standard of 20 or 30 PSF. You should think about using a Florida approved louver because they are pre-designed, depending upon the model, between 50 and 80 pounds per square foot. And because those are pre-designed for those higher wind loads, you could get away from doing calculations because they're already done, and it could improve or quicken your submittal process through the system, especially your engineering time. We're going to talk briefly about FEMA louvers. FEMA louvers or grills. These are high impact. You know, a Miami-Dade louver is rated for 110 wind load design PSF, 110 up to 165. FEMA louvers are around 266. A Miami-Dade louver is impacted with a 9-pound 2x4 at 34 miles per hour, or enhanced impact at a 9-pound 2x4 at 50 miles per hour. FEMA louver is rated for a 15-pound 2x4 at 100 miles per hour. So it's a very violent impact test, and it takes a very robust louver to meet that requirement. FEMA louvers and ICC code is what drives these louvers. So on this slide, what you'll see is the fact that a lot of people say, well, I'm really not in a tornado zone. But if you look at the wind zones in the United States, you'll see that the vast majority of the United States deals with some type of wind zones in the United States. And you can see basically what they call Tornado Alley in the middle of the country. But the map shows that most of the country deals with high wind zones. Tornadoes, one of the most destructive forces on the earth since the National Weather Service started keeping records in 1950. There have been over 5,600 fatalities, causing more fatalities than hurricanes and earthquakes combined. So the three codes and the things that you'll see in specifications that will drive a FEMA louver are FEMA 320 and 361, and they're basically the same. So you impact this louver with a 15-pound 2x4, and then you can't have any breakage, or you can't have a certain amount of deflection. So you see the picture in the right, how violent that is. It has broken that aluminum frame completely, but then if it stays intact, you're allowed a certain amount of deflection before it's a pass-fail test. But FEMA 320 is intended for residential or small businesses, which is less than 16 occupants. And FEMA 361 is intended for commercial shelters more than 16 occupants. That's really the only difference between those two. ICC 500 is the code that states that the following structures must include storm shelters when located in the 250 mile per hour wind zone speed. And you can see the 250 mile per hour wind zone speed takes up a lot of Texas, all of Oklahoma, Kansas, Missouri, Arkansas, Tennessee. A lot of states deal with that. If you're building a school system in any of those areas and they have a safe room application where students are supposed to go during a storm event, you will be required to specify and to put a FEMA louver in that structure. Fire, rescue, ambulance stations, emergency operations stations, police stations, schools K through 12 with 50 or more occupants, and 911 call stations. So you can see the 250 miles per hour wind speed area covers a good deal of the country. And the last thing I wanted to talk about is blast louvers. When I first started working at Ruskin 26 years ago, when people mentioned a blast louver, it was a louver that was probably went into a chemical room in a building, and there was a louver that was in an opening, and they would tether the louver to the building. They would put a chain or a cable on the louver, and if there was an explosion, it blew the louver out of the opening because of the pressure designed in the building. But it didn't go out and hurt people. But after Oklahoma City bombing, the GSA came up with a requirement for blast louvers, and this is truly an anti-terrorist louver. This is a louver that is tested to ASTM 1642. And the GSA code, if you'll see this in specs, and you will see this in specs if you're doing government buildings, if you're doing barracks or military hospitals or military facilities, they tested this to 4 PSI and 28 PSI. So again, if you look at a standard louver, it's designed for 20 to 30 pounds per square foot. A hurricane louver, 110 to 165 pounds per square foot. A FEMA louver, 266 up to 300 pounds per square foot. This is 4 pounds per square inch and 28 pounds per square inch. So what they do is they test it with an air blast. So you have the initial blast of 4 pounds per square inch, and then what they call the reflective impulse of 28 pounds per square inch. And that's what you'll see in most specifications. So if you go on Ruskin's website, you'll see a BL520, and that's a 5-inch wind-driven rain horizontal louver that we call our blast louver. And you can see in the chart below, again, the specification from GSA basically says 4 pounds up to 28 is the design load that you most often see. Ruskin tested ours up as high as 16.6 pounds for the initial blast and as high as 95 and 84 PSI for the secondary blast. So really what you need to know is that Ruskin didn't design or certify a specific louver for blast. We used the 520 as the one that we tested, but what we certified was our engineers, and we certified our engineers to do these calculations. So really all you need to know is we can help with this. This is a spec that you may see on government buildings, but if you do see it, we can help with the specifications, and we can design any louver that Ruskin manufactures. And we design about 128 different models is what we have as an offering. We can offer a blast louver in almost any of those louvers. There's some we can't because of the thin line construction of them and how they're built, or the material is really thin. But most Ruskin louvers we can offer as a blast louver. So all you need to know is if you run across this, we can help with both the spec and with calculating the design of the blast. And I believe that's all we have for me, so I will hand it back over to Tessa and Emma.
All right, thank you. So our Q&A session is now open. Please use the box on the upper right side of your screen to submit any questions you may have. We will respond to all questions we don't get to in an email following the conclusion of this webinar. If you have any further questions after the meeting concludes, please feel free to contact Emma Barnhart. So it looks like our first question is going to be, is Miami-Dade testing required for louvers outside the Florida in coastal regions?
No, it's not. Miami-Dade actually is only required in Miami County and Broward County, but you do see Miami-Dade as the basis of design. Texas Department of Insurance accepts Miami-Dade for testing in hurricane zones in Texas, like Houston. And you do see Miami-Dade louvers specified for data centers throughout the country. And I think the reason for that is because the design and the impact and the structural load, and also the fact that Miami-Dade is very rigid on how you install that louver, are guidelines that the data center people like when they look at louver performance.
All right, thank you. So the next question is, does Ruskin offer louvers with enhanced impact?
We do. Ruskin has multiple louver designs, EME 520DD and 420DD, for instance. Those two have just gotten enhanced impact. With the introduction of code, enhanced impact has become a major push for most louver manufacturers to include that, because in a lot of coastal areas, for instance, if you're bidding a hospital, those louvers will require enhanced impact.
All right, so the next question is, do any horizontal wind-driven rain louvers meet the Amca 550 performance?
No, they don't. They do only, well, I take that back. There are some models that meet it, but those models have either one, a damper at the rear, and like I said in the presentation, you have to have the damper in a closed position to match. There are also horizontal vertical combination louvers, and that is a louver that has a horizontal front to give the architect a horizontal appearance, but has a vertical louver at the rear. So the front louver has to meet Amca 540 impact, and the back louver is the louver that takes on the water performance. The drawback to those is that they tend to be deeper, heavier, and because you're changing direction of the flow of air from horizontal to vertical, they tend to be a little less free area and a little higher pressure drop.
Right. All right. And what is the impact for FEMA louvers?
FEMA louvers are a 15-pound tube of 4 at 15 miles per hour. So hurricane testing is 9-pound at 35 miles per hour, 9-pound at 55 miles per hour for enhanced, and the FEMA louver is a 15-pound tube of 4 at 100 miles per hour.
Okay, and do FEMA louvers require an additional wind-driven rain louver in the opening?
You do see that specified a lot. What you typically see is a FEMA louver. And when FEMA louvers first came out, they were intended to be outside of the building. It looked awful strange. We did some of those. They were outside of the airstream. They were in the airstream, but on the exterior of the building. And a lot of people didn't care for that because you had this 8-inch louver that was sticking out from the building. So they reversed them and put them in the airstream, which means now you have to deal with water. So you would typically see a FEMA louver in a sleeve with a wind-driven rain louver at the rear. Ruskin now offers a FEMA louver that is wind-driven rain performance all in one louver. So it meets the requirement of the impact, it is aluminum, and it also has wind-driven rain performance.
Right. All right, so it looks like we have a few more questions. The next one is, do Florida approved louvers meet the Amca 540 and Amca 550 performance?
Yes, they do. As far as Florida is concerned, the whole state of Florida has become Amca 550 required. It used to be just more coastal regions, but when the code changed, all of Florida became 550. So in essence, if they're truly going to follow the code, any louver in the whole state of Florida would require to either have a damper, be a combination louver horizontal, or a vertical louver. I can't say that that's actually adhered to. There are still horizontal louvers going up in the state of Florida, but Florida louvers are tested to Amca 540 and 550, but still it's only vertical louvers that meet 550 as a standalone louver.
Right. All right. And then kind of a follow-up question that you just touched on. Are there any horizontal louvers without dampers at the rear that meet Amca 550 water performance?
No, again, you can stop the water, but you can't channel it away from the louver before it overwhelms it. The only horizontal louvers that meet that performance either have a damper at the rear or they are a combination of a horizontal and vertical louver put together.
Right. All right. Thank you. So that's all the time we have for questions, and we thank you for attending today's webinar. We will be sending out an email after the meeting concludes with responses to questions, certificates of attendance, and a link to next week's webinar registration. That being said, please join us next week for our final webinar on October 21st at 1 p.m. Central Time for our discussion on industrial damper applications and selection. Thank you again for attending, and we hope you all have a wonderful day.